Hi, this is David Voss, CCIE 11372, and in this video we are covering WAN design considerations. We're going to talk about, at a granular level, things you need to consider when designing a wide area network. Also, we'll do a refresh of a few items that you'll need to remember in order to best understand the material that's presented in this video. It's important to know this information not only to be a strong engineer, but obviously to pass the CCDA exam. So let's begin. Now, for your CCDA exam, you must be aware that the enterprise edge design process must follow the PPD-IOO process, which is prepare, plan, design, implement, operate, and optimize. The designer should carefully analyze the following network requirements using this methodology: the types of applications and their WAN requirements, traffic volume, and traffic patterns, including possible points of congestion. Let's do a quick refresh of the PPD-IOO methodology. Cisco has formalized a network's lifecycle into 6 phases: prepare, plan, design, implement, operate, and optimize. And these phases are collectively known as PPD-IOO. Let's discuss the PPD-IOO phases in detail. First, the prepare phase. This phase establishes organization and business requirements, develops a network strategy, and proposes a high-level conceptual architecture to support that strategy. Technologies that support the architecture are identified in this phase, as well as a business case to establish the financial justification for the strategy. The plan phase identifies the network requirements based on goals, facilities, and user needs. This phase characterizes sites and assesses the network, performs a gap analysis against best practice architectures, and looks at the operational environment. In the design phase, the network design is developed based on the technical and business requirements obtained from the previous phases. A good design will provide high availability, reliability, security, scalability, and performance. In the implement phase, new equipment is installed and configured according to the design specifications. In this phase, any planned network changes should be communicated in change control meetings and with the necessary approvals to proceed. The operate phase maintains the network's day-to-day operational health. Operations include managing and monitoring network components and performing the appropriate maintenances. And then finally, the optimize phase, which involves proactive network management by identifying and resolving issues before they affect the network. Now, there is a design methodology for the first 3 phases of the PPD-IOO methodology, and there are 3 steps to it. In step 1, decision makers identify the requirements and a conceptual architecture is proposed. In step 2, the network is assessed. The network is assessed on function, performance, and quality. And then in step 3, the network topology is designed to meet the requirements and close the network gaps identified in the previous 2 steps. Let's review these 3 phases in detail. To obtain customer requirements, you need not only to talk to network engineers, but you need to talk to the business personnel and company managers. Networks are designed to support applications, and you want to determine the network services that you need to support, both now and in the future. So an example of design flexibility is VoIP. Considering the strict requirements of this technology, you want to make sure that VoIP can function over the design solution at any given time, even if this is not an initial requirement from the customer. But maybe a year or 2 or possibly even 3 years later, you will want to be able to support voice over IP. Flexibility in enterprise edge design consists of the ability to incorporate other technologies easily at any given time. Other key design criteria when considering WAN design include the following: response time, throughput, reliability, window size, and data compression. Response times are of great importance to the wide area network, as well as to its supported applications. Many modern applications will give an indication of the necessary response times, and again, VoIP is an excellent example. When a VoIP call is made over many network devices, you should know what the necessary response time must be for proper voice communications. Generally speaking, one-way latency should not exceed 120 milliseconds. You can test a response time using a feature on Cisco devices called IP-SLA. Let's do a quick overview of IP-SLA for you. IP-SLA allows you to monitor, analyze, and verify IP service levels. It's comprised of two components, a source and a target. Operations can broadly be categorized into 5 functional areas. Let's take a look at an example. You can use IP SLAs to monitor the performance between any area in the network, core distribution, and edge, without deploying a physical probe. It uses generated traffic to measure network performance between two networking devices. So as we draw this out, this shows how IP SLAs begins when the source device sends a generated packet to the destination device. After the destination device receives the packet, depending on the type of IP SLA's operation, it responds with the timestamp information for the source to make the calculation on performance metrics. It then can communicate with a performance management application via SNMP to provide real-time analysis of the network. It should be noticed that IP SLA can communicate with any IP device on the network that's enabled for these types of measurements. Another important design parameter is overall available bandwidth, or what many call throughput. This measures the amount of data that can be sent in a particular time frame through a specific WAN area. Reliability is another aspect to consider. This gives information about the health of the WAN connection and its resources, so whether this connection is actually up or down, as well as detailed information about how often the WAN functions as efficiently as possible. Window size influences the amount of data that can be sent into the WAN in one chunk. TCP uses a sliding window concept that works by sending an amount of data, waiting for an acknowledgement of receipt, and then increasing the amount of data until it reaches the maximum window. In the case of a congested WAN link, everyone in the network that is sending data via TCP will start increasing the rate at which they send until the interface starts dropping packets, causing everyone to back off and use the sliding window. After the congestion disappears, everyone will start increasing the rate at which they send at the same time until a new congestion event occurs. This process, which repeats again and again, is called TCP global synchronization. This leads to a waste in bandwidth during the periods that all hosts decrease their window size simultaneously. And finally, another key WAN factor is whether traffic can be compressed. If the data is already highly compressed, any additional compression mechanisms are inefficient. But that being said, especially today with SANs and other high capacity systems, compression over the WAN is critical to ensure that failover and backup services are ready to go live with the most accurate data possible. So here's what you've learned. You've learned about some unique WAN design methodologies, specifically a refresh of the PPD-IOO process, and then reviewing the key design criteria of WAN design, such as response time, throughput, and reliability. Then another refresh of IP SLA. All of this information is fair game for the CCDA exam. If you know the information in this video well, you will do excellent on this portion of your exam. Good luck in your studies.